Hello Gary, this is Sherman Ikimoto speaking. I have created this video to discuss a sales strategy that will increase product sales opportunities for Eaton and address the biggest problem facing data center operators today, which is runaway total cost of ownership for the data center. So in this presentation we will discuss at a high level the cause of these cost overruns and why this is an opportunity for Eaton to increase product sales, add a new and valuable data center planning service, and improve strategic relationships with operators. Before we start though, I wanted to bring your attention to a report from the 451 group about DSIM suppliers and how they compare to each other. All of Eaton's main competitors, such as Schneider, Emerson, ABB, Panduit, and others, are aggressively developing DSIM solutions. And 451 Group classifies each of these as having a comprehensive DSIM solution, the ones you see on the screen. These companies are going down this path to gain control of the data center roadmap, which would give them the inside track into selling their own products into the data center. And I know that Eaton is working on the same strategy, but by copying ABB, Emerson, Panduit, and Schneider, Eaton will only gain the last place on this list. So what Future Facilities would like to offer is a strategy for Eaton that will outmaneuver these competitors. And this is the topic of this video. So a good way to start the presentation is with this statement by Dr. John Coomey from the Steyer-Taylor Center for Energy Policy and Finance at Stanford University. He says data center capacity is an aspirational goal of the design, and achieving this goal falls on the shoulders of operations. So operators of government, enterprise, and co-location data centers are able to realize at most 70% of their data center capacity. This is by far the biggest total cost of ownership problem for operators. This is also an opportunity for Eaton to provide a unique physical integration service to reduce data center total cost of ownership for operators and unlock sales opportunities for Eaton. As operators build out the IT configuration within their facilities, data center capacity, the amount of IT load the data center can hold in kilowatts, drops significantly. And this happens because the tools and standards being used today for physical integration of IT equipment and the data center are simply not up to the task. Further, for historical reasons, operators do not have the engineering staff needed to perform proper integration. And this is a major problem for the operator and for Eaton because the operator stands to lose tens of millions in data center capacity, and Eaton stands to lose or experience delays in product sales. So to understand exactly how these things are lost, the build out of the data center can be equated to the game of Tetris. In Tetris, as the blocks drop in from the top, they must be physically arranged on the board so that they fit together tightly and use the capacity of the board efficiently. The time pressure to place the blocks and the fact that they come in different shapes and sizes will fragment and waste the capacity of the Tetris board. And conceptually, the Tetris challenge and data center operations are very similar, where the facility is the Tetris board and the IT equipment are the blocks. However, data center Tetris is much more complex, of course, because there are 4 resources to manage: space, power, cooling, and the IT equipment, not one. And often teams of people must be coordinated in the data center. Another major difference between Tetris and data center operations is the operator cannot stop at a partial IT load because the business will suffer. The load has to keep growing. When capacity is wasted, the only way to maintain growth is to renovate, relocate, or expand the infrastructure. And this drives up total cost for the operator by tens of millions of dollars and delays the purchase of products from Eaton. A second difference between Tetris and data center operations is you can't see the capacity fragmenting in the data center like you can on the Tetris board. We will discuss this issue later. Capacity utilization problems are much less common in highly uniform and pre-planned data centers like those from Google, Facebook, and Yahoo. But for government, enterprise, and co-location data centers, 1/3 or more of the facility at any point in time is a dead zone to IT equipment and cannot support an IT load. Again, this is a huge financial problem for the operator and a constraint on sales of products for Eaton because everything comes to a stop when the operator cannot fully load their data center. The capacity utilization challenge is recognized by the industry, but not many understand this problem fundamentally due to the way in which the industry has evolved from the IBM mainframe days and the emergence of distributed computing. Eaton has the opportunity to become an industry thought leader about capacity utilization efficiency, a relatively untouched topic today. To illustrate the financial impact of this problem, this graph compares the planned total spend on the data center to the actual costs. IT CapEx costs are not included because it is a fixed value in this comparison. Everything included for 15 years of operations, 1 megawatt of IT load will cost around $32 million. This cost covers design and construction of the facility and the cost of running and powering the data center. This value, however, assumes that capacity utilization efficiency is 100%, but this is not the industry norm as we saw earlier. After factoring in a realistic capacity utilization rate, we can estimate the true total cost of ownership. And note how low capacity utilization drives up the cost of every component of the total cost. So instead of $32 million per megawatt, the typical operator will end up paying $59 million per megawatt. So low capacity utilization efficiency, or CUE, is the biggest financial challenge for the data center operator. 30% or more of the data center will be lost. With so much at stake, why is this problem so common? Low CUE is common because operators lose sight of the capacity objective. And to understand how this happens, we have to go back to when the data center was first being planned. When a business identifies the need for computing resources, the management team will project the computing requirement for 10 to 20 years due to the costs involved. The computing requirement is then translated into construction, operating, and energy plans for the entire lifespan of the data center. The integration of these plans sets a total cost of ownership budget for the needed capacity that is signed off by the CFO, CEO, and board of directors. But immediately after sign-off, the budget is fragmented and distributed across operational teams and time. For example, IT will own a portion of the total budget, which on average amounts to about $1 million per year per megawatt of capacity. Their portion of the budget is spread out annually over the lifespan. This practice fragments the objectives of data center operation and changes the focus of the original integrated budget to annualized operational budgets. As a result, the operational teams undermine the capacity objective and each other, which makes it tough to keep the individual budgets in check. As this occurs, the total cost of capacity skyrockets. Making the situation worse, operators do not track total cost of ownership, so this massive cost overrun is invisible to the operator. Making the situation worse, operators do not track capacity availability either. This paves the way for the operational teams to plan the build-out in a way that meets their own objectives but ignores the capacity objective. Let's take a look at an example of losing sight of the capacity objective. In this example, the facilities team has hatched a plan to reduce energy consumption of this data center. They want to replace the standard blowers in the crack units with EC plug fans. This is a popular aftermarket best practice today that seems like a no-brainer because the new fans will deliver the same amount of air at 30% less power. But what most people don't know is that the new fans, even though they supply the same amount of air, will change the distribution of cooling to the IT configuration. This is the capacity distribution with the original fans. Every U slot is green because space, power, and cooling is available to each unit in this plan. This is the capacity distribution of the new fans. Many of the U slots have turned red because one or more of the IT resources is not available to the entire plant. In this case, cooling is the limiting resource. The new fans move some of the cooling from the IT plan to where it is not needed. This cannot be seen or measured. This is a problem because on a later date, operations will install IT equipment where cooling is supposed to be, but they won't know that it isn't there until they install and turn on the equipment. In this case, 75 kilowatts of fan power was saved, but 120 kilowatts of capacity was lost. In terms of total cost of ownership, $50,000 per year in energy costs was saved, but $465,000 worth of computing capacity was lost. So efficiency was gained at the expense of capacity, a classic case of being penny wise and pound foolish. The cause of lost capacity starts with the way operators spend money on the data center. The total spend is fragmented and distributed. This causes them to lose sight of the capacity objective. Today, tracking of capacity and total cost of ownership are not standard practice, which makes it easy to lose sight of the objective. Eaton can change this for the operator. Current practices have the operator taking responsibility for the physical integration of the products they purchase from Eaton and other vendors into their data centers. But operators don't have the engineering expertise to play the game of data center Tetris properly. Clearly, operators need help with integration of the hardware they buy from Eaton and others. Eaton has the engineering expertise in-house to help the operator integrate products from Eaton and other vendors. In effect, Eaton can transition from selling products to selling data center capacity, the resource that ultimately the operator is spending its money on. This service will unlock capacity for the operator and sales opportunity for Eaton. The integration service that Eaton can provide is based on a new simulation-based methodology for tracking and optimizing data center capacity. Eaton is using the software currently for in-house engineering design and some assessment services at the moment. The methodology is based on a 3D predictive model or digital clone of the physical data center. The model contains a complete physical description of the data center infrastructure and IT configuration down to each make and model of IT equipment. As the model is updated over time, by its nature it reflects the physical integration of the building, infrastructure, and IT assets. It reflects the data center as an integrated system. The model is built from a symbol library of all of the components within the data center, and Future Facilities has already built in a large set of symbols from the Eaton product list. The model tracks data center capacity as the physical configuration is built out over time. The real-time tracking of capacity is completely unique to Future Facilities software and not a standard practice in the industry. The predictive model is an inexpensive, risk-free testing ground to predict the capacity performance impact of IT deployment plans and other plans, and enables the operator to adapt the plans to ensure the path to full capacity is clear at all times. With Eaton in control of the model, the operator will have access to 30% or more of the capacity they would have lost otherwise. So this service in itself is worth tens of millions for the operator. With capacity freed up, product sales constraints are loosened for Eaton. Also, control of the model will give Eaton an inside track to the data center roadmap at the time when products are being selected from various vendors. This can significantly reduce the cost of product sales for Eaton. So currently, Eaton is selling products, infrastructure products, and integration services completely separately. Future Facilities proposes that Eaton sell data center capacity to the operator. And this product is a bundled set of product sales and physical integration services that are designed to deliver capacity to the operator. After all, this is what the operator wants. So thank you, Gary, for viewing this presentation. I hope you found it interesting and informative. Please email me or give me a call for more information or a follow-up meeting. If you are going to be in the San Jose area in January, please let me know and we can schedule you in. I'm going to be traveling a couple of weeks in January, so I'll have to work this out. So call me as soon as you can. Anyways, I look forward to hearing from you, and thank you again.